Um, I collected the data, and this is what the data table looked out. So the plastic ball weighed 7.3 grams, the marble was 22, and the steel was 66.8. I collected the 5 times for each of the 4 balls, dropping the 40 centimeters or the 0.4 meters. And then I did an example for the first one. So I did the average, I added them up, went to the same decimal place as the numbers are in the data table, divided by 5, and then went to that same decimal place. So you're going to have to do the same thing for this row and this row. And then I demoed how to do the acceleration equation. So it equals, the equation's there, so you don't have to write A equals, it's right there. But I went 2 times 0.40, because that was the distance that we dropped it from. I dropped it from, okay? And then I took the average time, 0.265, and then I squared that. And then it will your calculator will do this all perfectly in order of operations. You can actually type this all in, and it'll do the squared before it divides. And then I rounded to 2 sig figs because our distance was 2 sig figs. So I got 17 meters per second squared. So the plastic ball accelerated at 17 meters per second squared. So if it had fallen for 1 whole second, it would have been going 17 meters per second, but it only fell for a little bit there, okay? So you're gonna do the same for the marble and the steel, and then you're gonna do a graph, and it's the mass up here. This is your X versus your acceleration down here. So the first point is gonna be 7, I'm gonna go 7.3 on the X-axis, and then I'm gonna go up to 17 and put a dot. So we're just gonna have 3 dots on this graph. And again, what we're looking at is we're looking to see what is the acceleration doing as the mass increases. Does the steel ball accelerate faster than the plastic ball? And so if we see that, then our graph will go up. And if not, we'll be able to see the trend of what's happening there. So that's what we got there, okay? So you want to turn your page sideways or do this as a computer graph if you want. And then we want to number the x-axis by 2s and the y-axis by 1s, okay? So after you get done with the graph, then I'm going to want you guys to watch this video. And then in the middle of the video, it talks a lot about different things. And then all of a sudden it goes to this person holding a hammer, and it says, what will the hammer do? And then it says stop, and then you have to make a prediction. So I want you guys to actually predict what you think how the hammer will fall. Will fall handle first, head first, or as is. Okay, so circle that, and then describe if you were right or wrong, and then continue the video. So again, when you click on this is actually on my drive, and so that will come up, and you're gonna play this video, and it's gonna talk a lot about, there's a funny thing in here about push-ups and stuff and 0G and all that kind of stuff. So you got that going for you as well. Okay, so that's the video, and then just kind of going with that. It does a good job. And then I'm going to have you guys jump over to CK12. And in CK12, I can't make a direct link because you have to go through the login and stuff. But if you type in just cliff diver simulation, you'll be able to find this, okay? And then you're going to fill in another data table from this simulation, okay? And then you'll see keep air resistance at none and all that kind of stuff. And you can set the diver to dive from different heights. And then you can see the velocity when he hits the water. And you can also see the time to hit the water. So that's on the side. So we got there, okay? And then you're just going to answer these questions down here about, I can't go down. I can bring that up. Yes, okay. We're going to answer these questions down here about the cliff diver simulation, okay? And that's it. And if you need help with what scientists say, and did our lab actually back it up, this is kind of like a Mythbusters lab. The myth is, do things of different mass accelerate at the same rate? So we're going to either confirm, we're going to bust it, or it's going to be plausible. So that's kind of what we're going to come up with at the end there, okay? And so that's what we got, okay? Again, I'll be looking for your work in CK12. Again, completely optional. We are practicing for when this goes live, and so you guys can practice saving things as PDFs, turning in a computer graph. You could actually save that as a PDF, or you could send it as a Google Sheet, okay, file. And then if you do a hand graph, then taking a picture with your phone and then turning that into My Connect would be great practice for you guys just to learn some of these technology things as we go. And then make sure you show your work down here for the equation and you're set to go. Okay? Have fun and let me know if you have any questions. Talk to you later. Bye-bye.